Welcome to toddfun.com, and this week I'm finally going to do it. I'm finally going to review my Monroe 1651 engineering calculator from 1971. A friend gave me this, found it just a gem of an engineering calculator from 71. Over 40 years ago. Yes, this was somebody's pride and joy over 40 years ago. I don't even know if those guys even use the internet. So if they do and they find this, then let me know. I'd like to know how you used it and what your thoughts were. But I got it a year ago, and I was waiting to get my variac so that when I bring up this Nixie tube calculator, and yes, it runs on Nixie tubes. The display is Nixie tube. I didn't want this thing popping. I didn't want to just plug it in and just let it go, because if this thing pops, I'm going to be so sad. But now I got my variac. I've done some research, as much as I could find about the calculator, so that I can do justice to not only showing it to you and letting you know what it did, but also taking it apart. I want to take it apart and make sure there's no loose components inside, make sure there's nothing rattling around that would short out. When we power up, make sure everything looks clean inside, and then once we review that, we're going to put it back together, power it up on the variac, make sure it comes up with a proper currents. That is, we'll monitor the current, the AC current, and if all looks good, then we're going to start going over just the functionality of what this old girl can do. It's a real exciting moment. I mean, I literally waited a year for this, and I hope you enjoy this. We probably won't see another one reviewed in this detail ever again. I might even take this to work and sit it at my desk at work just for the fun. So let's get going. Now, the only thing that really looks like is in bad shape is this cord that's the power, and it is a funny connector, so I'm going to have to use it. I have electrically checked it carefully to make sure there's no shorts or anything. It's mostly just the plastics they used back then just can't handle the aging. But it is functional, but I will replace it eventually with something more, I'll have to do something to make that better. But for now, we're going to use this, and we'll power it up on the variac real slow, so we'll be careful. And after all these years, it still showed up with its little dust cover. So that is amazing that lasted so long. It probably just keeps the dust off, of course. It has a screen, because I'm sure it gets hot inside, and if you covered it up, it would damage it. They were very careful with this thing with screening. There's screens even inside here. If it'll focus, there's screens, and there's other vents everywhere. And they weren't going to let anything fall inside this thing. They wanted this thing protected from any type of environmental floating around. Well, let's just get going with it's just clean. Let's just take a look at it. That's the Nixie tube. I've cleaned it up. The best way to clean up plastics I've been finding lately is this stuff. It's plastic clean. I get it off Amazon. It's not expensive. You can get microcloths with it, and it really is. It's really safe on these plastics. It gets all the dirt and grime out, and it's not aggressive on anything. And so this cleaned up real nice with that. It's an engineering calculator, which they marketed. Monroe marketed this calculator for engineering back in 1971, and it comes with a lot of math functions, and we've got trigonometric trig functions, logs, got pi, a dedicated button for pi over here. There's second functions on some of these. It has, I believe, 9 memories that you can work with. You can go into exponential mode and out of exponential mode. So it's just an amazing calculator for 1971. I'm just tickled pink to see this thing. I'm really excited to see if it runs. I'm going to be so disappointed if it has issues, but maybe if it does, I can fix them. Now, of course, you can go over real easy number-wise. It doesn't have. I think this is called 11 plus 3 display. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 plus 3. Yeah. So these would be your exponents over here, and you can have an error code pop up here and an overflow over here. And and this is the floating point version. There's other Monroes that are from that era that you have to set the decimal position where you want the decimal to be, but this one's floating point. The 1651 is not programmable. I really wish I had the 1655. That would be super sweet, because then it would have programming buttons up here for doing some programming, and then you can have it do up to 128 program steps. Think about it, 1971, having your own little mini computer calculator on your desk. That would be just brilliant. And more fascinating would be the fact that if this was a 1655, then in the back there would be a connection, which this one does have a port for. You would hook up to a card reader and a punch card. You know, the old punch card programming concept. And you'd take a stylus and you would literally poke holes in your punch card, and then if you got the card right, then you put it in the reader and it'd read through and then come into your calculator, and you could load up to 128 steps. But you could actually have a memory expansion for 256 steps. So there was that, and really I was reading about it, and it's pretty interesting. If it did that, you can be making a card, and if you make a mistake on a column of numbers, there's another place to punch that says no, ignore that column, and then you can go on to the next column, and it just when the card reader reads it, it just ignores a single column, and then the card reads through, and all that done by hand. You don't have to do anything. Now they had even an older one, a newer one, in the sense that it actually used magnetics. There's still cards, but the cards you could program the cards, and then it would read them magnetic strips on them, kind of like a credit card. So at any rate, that isn't what this is. I just want you to know there's a lot of varieties, and they reuse this case. Now, the Monroe calculators have been around forever. You know their name, I'm sure. Now, Monroe does not make the innards of this usually, and most of the innards of their calculators back then was made by a company called CompuCorp. I think a combination of computer and corporation, and they called themselves CompuCorp. And they were the actual designers of the electronics and stuff in here. So when we get it open, I wouldn't doubt if we see CompuCorp on some of the product in there. But you know, the 1651 may or may not have had something done by Monroe in there. I didn't see a lot of material out there saying that they outsourced it, from what I could tell. So I got it upside down. It's just 4 screws to take out, but let's zoom in and see what we have. We have, well, let me flip it around so it's readable. So it's got Monroe, a division of Linton Industries. That's because I believe they actually purchased and or merged with Linton, so that was kind of why there's a double name there from what my research shows. Could be wrong. The model, and here's a serial number. Serial number is, let me read it, E010215. If you happen to know that serial number, and this was yours, oh, please let me know. I would love to talk to you. Even if you just had one, that would be fine. And so let's crack it open and get inside. So before you start tearing apart electronics, you want to be safe. ESD, I got my ESD grounded mat. You want to put it on your wrist strap, keep it plugged in. These are very hard to use though when you're shooting with a camera and you have all your hands on your camera and you just tangle up so much. I have an extra long ankle strap that goes around my ankle, and it's got a long distance on it, and I can work all over my bench here, and I stay grounded to my ESD system the whole time. So there's a good tip for you. Last screw, and they all look to be machined screws into metal inserts, so they spared no expense. Well, here we go. My first look and yours. What's inside? There comes the bottom. It's got this. It's got shielding here too. I think this screen is more for shielding than for debris, but oh, there you go. Take a look at that. Well, let's do a little flyby. Well, this is the very bottom, so let's fly in and take a look at some of the stuff that I'm noticing. So this very bottom board is the ROM board, the ROM Logic, and it's got its model number for its board. What's interesting is this is all like a fiberglass board for the printed circuit board, where there's no solder mask or anything. There's just etched traces that are left open, but they're all then like wave soldered, or in a sense there's no silk screening to mark where things are. So if they want to mark like pin 1 and pin 28, and if they want to put any marking on the board, they simply do it in the etched trace foil, basically. And if they're going to have vias and stuff on this 2-layer board, they just have solder-filled via holes. Most of the stuff on here is pretty it's pretty thick traces. There's a few thin traces. I think I can see through the other side, and there's some fairly fine traces on the other side we'll look at when we flip it out. This is, of course, CompuCorp, as they call themselves, or this is the copyright 1969 Computer Design Corporation. They're really crazy about labeling their quality. Like every part must have been tested and labeled and stamped. This is CompuCorp 4, that's their stamp on this board. Here's CompuCorp tested 2, probably the second side of the board, or just second someone's number, who knows. So they really must have been handled by a lot of people. Not sure what this is. It looks like almost some sort of PCB board artwork. I don't know if that's a logo of someone's, or maybe the people that etched the board or something, but at any rate, that was interesting. These, if I can zoom out a little bit, you can actually kind of see the legs inside of these traces inside these chips. This is what's considered essentially large-scale integrated logic, where all these different chips on these boards kind of have their own modular point or job, if you will, and they get hooked together based on what kind of features you want, and then together they make what we would normally call a microcontroller nowadays. Whereas this is the smallest they could make it by adding them and putting them together. So this would all kind of condense down onto a little chip nowadays. Most things look just amazingly well constructed. There's a couple of items here that aren't populated. I tried to find this chip and I couldn't. I'll let you take a look at that if you want to try and figure out what this Texas Instrument is. And if you look, it's got a date code of 7123. So that was 1971, 23rd week, and that was the oldest chip so far. A lot of these are that large scale integration logic I told you about, and they all have their own little markings on them. And like it's the HTL 18 would be this. It's the 18, and you'll see this is an HTL 10. And there's a web page that was giving me a lot of information. These are made by AMI. You can kind of see their logo in that name, and they're the ones that make essentially the producers of these chips. This must be where the power comes in down here. The traces are bigger. Look at the detail to the wiring, though. Is this amazing or what? Everything's nicely zip tied, and then even when they just soldered into these things, they didn't leave it at that. They actually put not a shrink wrap, but like a plastic tubing over one of these connections. I mean, they're just not leaving anything to chance, are they? Normally they'd just be soldered. You wouldn't even shrink wrap something like that, but I guess they do. So what we'll do now is we'll go ahead and pull this ROM logic board out and flip it over and see the other side. I'm going to have to pull out a couple of these board connectors that you see here to do that. This is the tape that was just there for extra support, but it is just gone. That tape has had its day. More attention to detail. This metal edge has plastic or sort of a rubber covering on it just in case there's a wire going there. There isn't one in this design. But if we come over here, this wires are dangling over here, and they didn't want to even risk these wires getting cut by this metal. That is attention to detail. Okay, the ROM logic should come out. If I just pull on it, there should be nothing but an edge connector. I don't think this has been out probably in over 40 years. Might be something catching on it here. Yeah, that's just a... There we go. First time out. And there's a rubber just so the board won't flex. Look at that. This board is not going to flex, but they put a rubber on there just in case, rubber pad just in case it flexed. And no stuff on this side. Just a lot of vias and stuff like these chips. There's these vias all on the other side. They just go to this chip. So if I flip it over, you'll just see those go down to the next chip, on and on and on. That's how they did that. Looks nice. So here, it looks like there's a connector here that's not populated. It would be interesting to know what it was supposed to be for. More quality marks on this. This is the back side of something that we'll flip it over and see what it is. Gotta pull off an edge connector. And then another edge connector. This is where the tape came from. And then this should come out of that back plane. Sorry. Boy, I'm glad they make this stuff tough because it is stuck in there good. Looks like something can connect over here too, but I don't know what would connect on this side. I'm sure because they made different types of calculators, they wanted these to be easily integrated into other types of products. Well, I just don't want to damage anything after all these years. Ooh, this one's dusty. Okay, let's blow the dust off. I'll be back. There, that's cleaner now. This is, they got silk screened on here that this is the input-output logic board. A lot of it is not populated, and like I was saying, that this wasn't connected to nothing, and this wasn't. So I'm thinking maybe because the 1655 had the ability to be programmable as well as have a card reader, this might have been populated for the card reader and then going into the programming features that the 1655 would have. Let's go deeper. There's a few more edge connectors here, but some of the wiring goes through different areas here that looks like it'd be difficult to take off, but it's very modular looking, so I'd be surprised if they put something on and then soldered it. So maybe I have to pull this thing up out of this chassis and flip it over. But while we're here, this is the transformer for the mains. This is that input plug. Looks like there might be a breaker here in case of overload maybe. Interesting enough, we can see that there's some connectors back in there. We'll probably get a better look at them in a minute. But yeah, something was supposed to be able to jack into here. I'm going to just lift this out of here, I think. I think that's the plan, is this just lifts out. And then we probably flip it over. And this is just the top shell, so we'll put that aside. Well, certainly they made electronics serviceable, that is for sure. There's our Nixie tubes. And I'm going to do a little cleanup here and get right back. I'm just going to blow off some dust. Wow, what a fun investigation this is. I mean, look at that. Every time they had a wire come off of that bundle, they put another wire tie or zip tie all the way across there. What attention to detail. And let's see, here's the Nixie tube displays. Now we'll zoom in on one and see if we can get a good view of it. So you can kind of see there's like you can see the shape of numbers in there. So this vacuum tube will have different essentially paths through an element that gets heated for like a 6, an 8, a 7, and they're basically layered. One layer the front layer will be like a 1, the back one will be a 2, 3, 4, all the way back to like there'll be like a 8 or 8 all the way in the back or something like that. I'd have to look up the exact design, but each number is made separately that way inside that vacuum tube, and then of course there's the emission is just onto a grid, just your normal stuff there. But fascinating that they can do that with these, and I really hope they all work. They sure look like they're in good shape. I'm thinking if I take out, well actually if I was going to look over here, there's just like a little neon light here and here for the overflow and air, with a little piece of sticker in the back, and then this metal shield to keep the lights from crossing over. I think I can take off these two bottom screws, and then this whole Nixie tube display just pops right out. And I can get to those two screws on either side right here. But look at that, they painted over every nut and bolt in this place. And you know, it's like shake-proof washers everywhere, and then painted over every piece of thread. That's not going to come apart. Seriously, I wonder what this thing cost in today's money to have all that manual labor. So those screws came out pretty easy, and it's on a back plane, so this should, if I'm careful, it should just pop out of that backboard. It's in there real tight. There we go. There's your display. Popped right in. Looks like they got all these labeled. I'm reading B5866ST Nixie, N-I-X-I-E, registered name, made in Japan. I wonder if they're all... This one's going to be something different because this is the end indicator. Well, this will be a number here. The B583 B 5853ST Nixie. And the rest of them should all pretty much be the same because they're all just numbers. And then it'll be different than maybe, no, they're all the rest are just straight up numbers. This one might be a sign right here. It's a 5866ST. And the other ones are 5353. Yeah, the rest are all just straight up numbers. That was stuck in there pretty good, but yeah. Soldered in with the little spacers, little standoffs. They're not plug-in though. They are soldered. They are soldered down in there. So it's not like you can just say, oh, this one's dead, pull it out. You would have to actually unsolder one of these and solder a new one in. Brilliant. So we're looking at the back side, and you can see this harness with all these cable ties. It basically goes down to this control board for the Nixie tube display, and it comes off the side, and that's what hooked up to that logic board that we pulled off. That second board that we took out is what that one hooked up to. And I think next, in order to do any more disassembly, we're going to have to take out this this kind of more of a power board or some kind, because we have to get to a few things underneath here first. We have to get to these screws up here before we can take off anything else. But like I was saying earlier, there's a couple like Molex connectors on the back for something. I'm not sure what. This one actually just has jumpers going back into itself, but it could be for diagnostics or voltage testing, or maybe it was for powering an external card reader or something that you would just snap in right there, but I wouldn't know without more details. And this is should just pull right out actually. It doesn't. It is very modular. I don't think there's any wires to be had. It's just a, there we go, just like that. Well, look at that heat sink on there. That transistor must get pretty hot. And it's a pretty big spring-like style heat sink on an MM4000 Motorola. I wonder what it is exactly. Looks like it gets hot though. We have a 2200 microfarad 25 volt DC cap, and then a 500 millifarad 50 volts DC, and finally on that's a brilliant name, an atomic. Gotta use the word atomic in 1970, you know. Oh gracious, 40 microfarad 250 volts. So this goes on the mains. This is 300 volt surge. So these are the paper ones that can dry out, and sometimes they have to. When they dry out, you'll have problems, and those have to be replaced. But this board looks more like this doesn't look like those heavy, heavier boards that we pulled off the bottom. This looks closer to more standard green board. It actually has solder mask on this, so that's. I didn't expect to start seeing that little bit of a technology change on that at all. But what do we have here? We have Surgy. And this can is marked 2N3725. That's these cans. Looks like there's a bit of a pot. VDD here. It says VDD ground and VGG. A pot that has a little bit of glue on it to keep it in place. See, these are date codes there. 71, 26 week. Some of these things I don't even recognize. I mean, transistors, of course, but I don't really recognize that right off. I don't take apart enough old electronics. 6R80F, 35 volt. Plus, minus, could be some kind of a heavy diode, I guess. They do have some marking. This is the plus side, so I'm thinking maybe diode. That has a little diode symbol right beside it. You can see at the top of my thumb, but that's for this Zener. This could be a cap too, I guess. I really don't recognize a lot of this older stuff. I wasn't, but 5 years old, I suppose, when this came out. 3? No, I was 4 years old when this came out. So I'm sure it was designed before I was born, maybe. Because 69, no, it would have been a little bit after, but still, I'd have been a little guy. So yeah, the power regulation board. I looked this one up, and it is a PNP signal transistor. As far as this number is concerned nowadays, it seems like you can still even get it. These, I think, are thermistors right here in the power part, and that's why they're probably you know, that's the number I looked up, and that's what kind of popped up. These are a couple of bridge rectifiers, and of course you need that to convert your AC into DC. Not much else to do here except for we may be out of luck with this machine. If we take a look at this poor little fellow right here, I don't know how clear you're going to get it, but those leads are black, and this is kind of bulged. So not only is he bulging, it looks like, but it looks like it outgassed, and then that heat and outgassed and oxidized those two leads. So we may find ourselves in a bit of a non-functional event, and if so, this will be our first culprit. It's a diode for sure. I just wouldn't know its spec. I can see the diode symbol on the stripe on it, but there's a diode symbol under it. And there's nothing on the back side other than just some shiny traces. They definitely don't want you to work too hard to take this apart, because all you do is loosen up the screws on the side, and then this Nixie control board just slides right straight up the front. It's going to have a wire on the side though, so we gotta, when we get up, we have to kind of come around with the wire. And it's tied into one other thing, so I'm going to have to see if I can coax it around here for you. It's tied into this actually. I wonder if I can unplug that, and then I can examine it in my own free time. There we go. That just plugs in green to green. That's easy to remember. And okay, we have the back side of this Nixie control board. Not much other than a bunch of quality control marks. That seems like something they're pretty hip on doing. And on the front, that's where the Nixie tube plugged in. And I'm going to pop this board off, or this riser, if you will. This is what, you know, shields the Nixie tubes, just so we can take a good look at everything. You know, gotta see the whole thing. Well, just a couple of screws, and that back plate comes off, and we can take a look at this control. So it's essentially a lot of transistors coming up from the logic control. So it's going to say, you know, I want number 9, and then this is going to help do that. We have a chip over here. It's an SN. Oh, it's a 7442. Yeah, okay. And a lot of transistors, of course, because the signals are going to come through here in order to turn all those lines, power and off. They got lots of string tie down, so nothing comes off, and they're serious about putting stuff together, weren't they? Jeez. And let's see, this is the driver board, which makes sense, of course. I don't see anything burnt or damaged, so looks like we're good with this one. So there's not much really to take apart here. We've got the transformer. These two connectors, which didn't go to anything, they are wired up to. Well, they got wires coming over this stuff, but I'm not exactly. They don't connect to nothing, so why these are there, I don't know. This is just jumpers. This green one went to the goes to the power regulation board. This goes over to the on-off switch, which is right here, on-off. And so there's a little wire coming up, and I suppose that's why they're serious about insulating this in tubing, because it is the power on-off switch. This is a 2 amp circuit breaker with a button on the back, so if you overdo it, you got that. This is just a really serious noise suppression filter. They didn't want any noise getting into this electronics whatsoever. Yeah, it's really hard to trace these wires because they go into these bundles, but I'm thinking because it's on, these are like power transistors hooked up to these sides as heat sinks. There's one on each side. They, for the most part, they trace into the bottom of this power conditioning, this power regulation board here. They come in on either side of this, and it looks like they come up through some pretty heavy resistors. Maybe they're splitting the power load evenly, or maybe one is doing the Nixie tubes and the other is doing some other regulation. But you know, it could just be, you know, it looks like it could just be keeping it separate. This side of the board might be powering one thing, this might be powering another. I'd have to sit and trace it all, and it's not worth it. But at any rate, those are that. And so yeah, okay, that's the most I can do right now without spending way too much time reversing. I just want to see more about what they did in the technology. The only thing left then is just the keyboard, and they were serious about their keyboards too, weren't they? I mean, we got these buttons and these big spring rubber coated containers. Not much I can do to get inside that, I don't think. I'm going to see if I can't get in a little bit, but most likely I can't. Yeah, it would be a bugger to get into these. These caps would all have to come off, and they're really sort of, once they're put together, they're just bolted. There's just 4 screws holding this board on this chassis. That just would lift. It wouldn't do anything. It would just lift off this chassis. And you wouldn't be able to see anything other than if I flash in there, you can see there's just an assortment of Zehners and resistors and some looks like some caps, some bypass caps or something, a few transistors. They all look like they have date codes on the buttons if it matters. I don't see part numbers, but like here you can see a date code of October 70, and I found some that were as late as June 71. So they're just using some older stock on some of these buttons. But there, that's about all the deeper I can get into this for you. Let's assemble it and play with it. Well, my Monroe 1651 engineering calculator is all back together again. It is ready for that power on test, but this is my third video today. I've been trying to get a bunch of videos in the can so that I can have time to edit them during the week and or following weeks, and because editing takes more time than it does to shoot the videos, and it takes a long time to set up all the shots. So 3 videos in one day, I'm pretty tired. So I'm going to see if I get this one edited and up to YouTube first, because it is the one I promised last. Please join the next video where I'm going to power this up and demonstrate it. So this video is just going to be the teardown and introduction. The next one will be powering up and demonstration. I did test that diode. It tested good, even though it looked pretty bad. If you didn't skip through the video, you know there was a really bad looking diode on the power board. But it tested fine, so you know, it probably hold up. Thumbs up, subscribe if you like this type of content. The more subscribers I got, the more money I make from ads, and this makes it more of an incentive for me and a value to bring good content to everyone. So thanks for joining, thumbs up, and see you in the next video.